All right, find the vertical asymptotes of any of the graph of the rational function there. All right, it didn't ask for it, but let's go ahead and let's start with domain. It's a good review thing, and it'll help us build to the big question at the end. How do you find domain of a fraction? Set what not equal to 0? Good. The denominator cannot equal 0. So what's my denominator here? So x squared minus 1 cannot equal 0. How are we going to solve that? Can I factor it? Yes, it's the difference of squares. Could I just move the 1 to the other side and take the square root? Yes. Which way do y'all prefer? Difference of squares? All right, so it's the square root of x squared. And the square root of 1? And what I put in the parentheses? Plus and a minus. And set them both not equal to 0. And solve, right? Oops. Oh, there it goes. It was lagging. Sorry about that. All right, so if I think about my number line here, so it can't equal -1. It can't equal 1. So what can it equal? Yeah, let me label my infinities. That'll help us too. So it can equal -infinity to what? All right, so -infinity to -1. What else? -1 to 1 and 1 to infinity. In a minute. All right, so we got our domain. So now let's go find our vertical asymptote. How do you find your vertical asymptote? See, uncancelled factors of the denominator set equal to 0. So I need to go see, can I factor anything here? Well, you just told me we could factor that denominator, right? So x plus 1 and x minus 1 was what we had. I just pulled that from the domain there. And I can't do anything to the top, can I? Does anything cancel? No. Both of those x's are superglued with 1s, right? So nothing cancels. So my uncancelled factors of the denominator, that just is my denominator. So it's going to be that x plus 1 times the x minus 1 set equal to 0.
That's your vertical.
So set them individually equal to 0 and solve.
Wait, what's the difference?
They're not equal to and the equal to. Honestly, on this, because nothing canceled, they're going to be the same. That's why I said let's look at the domain, because the domain and the vertical asymptote are very closely related. Your vertical asymptote will always be a restriction in your domain. It may not be the only restriction if something canceled, but it'll always should come out of that domain there, okay? And so my vertical asymptotes then, we have 2 of them. They're equations, so you have to write x equals in front of both of them. So I got it x equals -1 and at x equals +1.